Okay, so let's talk about arithmetic series. First, the definition and what that is. The arithmetic series is different than arithmetic sequence. So notice that in arithmetic sequence we have commas. See these commas between the terms right there? So it's the commas between another term right there, another sequence. But it turns out that with series there are addition sign, plus sign, and it could actually sometimes will be subtraction sign, which is actually a positive, the plus sign, addition sign. But that's what that is. The series is basically the sum of all terms of the sequence. We call it a series. I mean, they show up in the form of a plus sign. It separates the terms. All right, let's look at this. We want to find the sum of the first 10 terms of this sequence or series. So we want to go through a couple of things. First, the first 10 terms we can easily find out. This is arithmetic, so we know that the common difference between the two is positive 3. So basically we do know that. So D is 3, and then we just go through it, and notice that what I've done here already for you. So this is your 10th term. T10 is 26. Okay, great. Now here's what I want you to do. So we want to find what the sum of the 10 term is. This is S, okay, for sum. All right, now notice that there easily you can take out a calculator and you can just add all of these numbers and you're gonna get a value, okay, which is very simple, and you'll get it. That's not a big deal. However, I want you to see a pattern. I want to show you what happens when you actually reverse the sequence and write it underneath the original sequence, but obviously will be in a descending order. We now add the S's. Notice that every time, so if I add the first, let's say we have a S10 and S10, so we have two S10 on this side because we are adding, okay, we are adding these two together now. So we're adding the two equations together, so 2S10. But notice what happens every time we add these terms. We get 28. How about next one? What do we get? Oh, 28 again. Okay, is that a coincidence? I don't know. Let's do it again. Will we get 28 again? Yes, we'll get 28 again. And notice that you can just keep doing that all the way to the end. Well, you get 28 again when you add these terms. So you get 28. How many 28 terms do we have? Okay, so in this case we're going to rewrite this as the equation will be 2 times the sum of the first 10 terms equals to 10 times 28. There are 10 of these, 10 terms, right? We can count them, that's what they are. And then we're solving for the sum of the first 10 terms, so you have to divide both sides by 2 because we want to get rid of this 2, right? We want to get rid of that, so let's divide everything by 2, We get S10 equals to 5 times 28, which is 140. That is basically the shortcut of adding all of these terms. And now in this case we only had 10 terms to add. What if this sequence had 500 terms? Well, it's going to take us a couple of years to add them using our calculators. Okay, that's an exaggeration, but you know what I mean. So it takes a long time. So we are now, based on this, we have developed this formula that actually follows exactly what we just done. And the formula for that becomes, and you guessed it, Sn equals to, first of all, this 10 was what was this 10? This 10 was the term number, right? So this is the term number. So it would be n. So that's what that is. Okay, so n. What did we do? We divided that by 2. And then what was the 28? The 28 was the first term plus the last term. Wasn't that the case? So first term plus, now the last term of the sequence, we call it, in this case is T10, but let's call it L for the last term. So this is the last term of the series. And sure enough, that's what we did, right? So first plus the last, first plus the last, okay, or other way around, first plus the last, first plus the last, right? So so this is one form of that, and from this point on, now remember, L was T sub n, okay, and you can substitute that as well. That's not a big deal. So remember, the T sub n, what was T sub n again? The general term of arithmetic sequence was a plus n minus 1 times d. So you know that you can replace L with Tn and then go ahead and solve. Okay, so here's a question. For the arithmetic series 6, 8, 10, 12, find its S50, subscript 50, or sum of the first 50 terms of the series. All right, so notice that this sequence or this series doesn't have your 50th term written here for you. So when you write up all the information here, which you do right here, okay, so all the information is given to you right here, that you write up in a column form. Notice that T50 is missing, so perhaps it would be an easy thing to do to start with T50. So what is T50? And we're going to use the Tn, the general term formula. So you just go ahead and plug that in and find out what that is. So 6 plus 50 minus 1 times 2. Do the math and find out what T50 is, and then let's go from there. So you get T50 equals to 104, and then now that once we have the T50, that is great. Now we can go ahead. So here it is, S50 equals, and we're going to use the sum formula, which is n right there, n divided by 2, the first term plus the last term. So let's plug in numbers. N is 50 divided by 2. First term is 6. Last term is 104. And then we're going to do the math. That's 25 times 110. And that is 2,750. So the sum of the first 50 terms of this sequence right here, this sequence right there, is 2,750. Notice that in this formula right here that we have, this formula right there, the sum formula, there are 1, 2, 3, 4 terms or 4 variables in there. So any of the 3 must be given to you for you to be able to solve the 4th one, okay? And since this is just the algebra from grade 8 and 9, I assume that you can go ahead and do those. But in general, you want to solve for basically the sum value, okay? That is it.